So today we're looking at chapter 12, day 3. We're going to focus on the parabola. And as you look at it, you can see the parabola sitting over there to the right-hand side. And that's just the basic picture that we have that we know and we've become accustomed to. But you can see that there's some extra information in there that we haven't looked at before that we're going to focus on in this idea of conic sections. Okay, so right away you should notice the difference. If the x quantity is squared, it's going to be a vertical parabola opening up and down. If it's a y quantity squared, it's going to be the horizontal parabola opening left and right. Now the vertex in either equation, it's going to be the coordinates h comma k. Look carefully in the horizontal, the k is listed first because that's always going to be with the y group. So make sure you notice that as you're going through when you write your equations and figure out your information. Okay, that'd be the tricky part. Now the focus is this point right here that we use to draw out our whole parabola. That actually has a big importance with that. And that focus actually has a lot of applications too for some of you guys that go into engineering and other fields like that. You will look at that focus and where the location is to maximize output of different lights and sound, and I'll leave that for you, down the road. Okay. So, but this focus that we need to look at, this is actually P units away from the vertex. That's where that P comes in, as you see in the equations at the top there. So that's going to be P units away from the vertex. And so what we can say is if you have a vertical parabola, what it'll be is it'll be h, and then you'll take whatever the k value is and you'll add to whatever p is. Okay, so there's where the focus is. Now the directrix, the thing about the directrix, it is exactly also p units away from the vertex. Okay, and so what we'll do is we're going to get a line that is perpendicular to that axis. Remember your axis from algebra class. And so we're going to get that directrix is perpendicular to that. So we know that when you write an equation, that's the big thing, is that a directrix always need to be an equation. We're going to say that it's y equals, well, since we went the opposite way, it's k minus p. If you have a horizontal parabola, you're going a vertical directrix line. So it's going to be x equals that h minus p. Okay, the line from the focus out to the parabola. And if you were to go straight down, if we had actually had a really good accurate diagram here, these two lines are always going to be congruent to each other, no matter where you are on the parabola. Okay, so that's an important significance in terms of drawing your graphs, all right, that we'll look at later on. But as you look, what that actually is when you look at the diagram, and I'm going to move this blue line here for a second, okay, if I were to go parallel to my directrix through the focus, hence focal width. If I were to go through there, that green line is my focal width. Okay, so that's going straight across, parallel to the directrix, perpendicular to that line between the vertex and the focus, all right, and that goes straight through the middle there, and that helps us draw. We'll use that as we do some of our examples here in a little bit. Okay, y equals a parentheses x minus h squared plus k. That's you did back when you were doing all your algebra class. But we're not going to use this now. We're actually going to use the Conics form in this part. And this, like I had listed up above, if it opens up or down, x minus h squared equals 4p y minus k. That's the equation that you need to understand and memorize, because that's how your answers need to be on your tests and quiz. So to avoid losing silly mistakes because you have it in the wrong form, put in Conics form. Now the Vertex form, which we probably never have used, is x equals a y minus k squared plus h. Again, you need to know that form because we're not going to use it. You're going to be looking at if it opens left and right, you're going to be, as I listed up above, y minus k squared equals 4p x minus h. Those are the ones that you need to memorize and be able to use over and over and over again. It's going to open up if p is greater than 0. It's going to open down if p is less than 0, right? That just means if p is positive, it opens up. If p is negative, it's going to open down, okay? Now, the other one that you can see is, well, how do you know if it opens left? Well, that's if p is less than 0, it's going to open left. If p is greater than 0, it's going to open right as long as the y quantity is squared. So the first thing you should identify when doing any of these is it x squared or y squared? Well, looking at that equation, hopefully you recognize, oh, it's y squared. So we know that this is going to be either, this is going to be a sideways parabola, either going left or going to the right. And we got to make that decision. Either case, we know that our vertex is going to be 5, 3, because here is your h value, there is your k value, just like we do with circles. The x coordinate goes with the x, the y coordinate k goes with the y, right? You got your 5 and your 3, okay? The next thing you're gonna do for all these problems, and this is the next thing that comes in here, is you look at this 8, and it's there for a reason. If you remember from up above, as you can see that we have this equation up here, right? We know that 4p is equal to 8. So because 4p equals 8, we know that p is equal to 2. Well, the significance of that is because it's a positive number, we know that we're looking at a parabola that opens to the right, okay, because it was y quantity squared and it was a positive p-value, so it's opening to the right. So when I want to figure out my focus, right, so if I would draw a little bit nicer one here, we have that this is your vertex. To get to the focus, it's always inside. So all I'm going to do is take 2 steps inside the parabola when I want to find the focus. So you can either go up to this equation, right, that we had at the beginning, and it says you want to find the focus, that we could go through and do h plus p comma k, and you can memorize that and use that, and that's perfectly fine. But like I said, if you're a visual learner like I am, what you may want to do is say, well, if I start at 5, 3, and I take 2 steps to the right, my focus is going to be at 7, 3. And that will give you the coordinates of that focus. Again, if you're great at memorizing equations and you'd rather use that, if you remember the equation for the focus when it's a horizontal parabola is h plus p comma k. So if you'd rather do this because you memorized it, 5 plus 2 comma 3. Oh, look, you get the exact same answer, which you should. It just depends on what your preference is. If you're a visual learner like myself and you want to just draw it out and start plotting points, that might be easier. If you want to use the equations because you're great at memorizing the equations, then use that, okay? You can use either way to get your information, either from the vertex or the focus. But everything starts with the vertex. You got to make sure you find that correctly, all right? Let's take a look at number 2. State the vertex and the directrix based on this. Well, looking at this, x quantity is squared. So I know I take that and do the opposite. I got -3 and +1, right? Comes right from there, comes right from there. Okay, just like doing the circle, right? The vertex or the center of the circle. Exact same concept. All right. Now, since it's x squared, we know that it's going to open up or it's going to open down. And we have to make the decision. Which one is it? Well, hopefully, if you take a second look at it, if you guessed it and you said, I see that I have a negative, so I know that it opens down, you would be correct. Okay. And so what we can do is we can go through and say, all right, well, I know that 4p is equal to -20. That's just in the equation. It's always that number that's in front there. So p equals -5. So that's why I said, if you said opens downward because the p is a negative value, you were right. Now, if you take a look at your graph here, so if we were to look here and look at a quick graph, we're at -3, 1. We'll see right about there. There's our vertex, okay? We know that it opens downward because we have the negative p value. So if I were to graph one that opens downward, my focus would be down there, but that's not what it's asking me for. It's asking me for the directrix. So I would have to go the opposite direction, and there is my directrix, okay? So because it's a horizontal line, I know that my equation is going to be y equals, well, if you started at 1 and you went 5 steps upward, right, to get away from the parabola, so you'd go upward to get to that directrix. Well, instead if I start at 1 and go upward 5 steps, I'm going to be at y equals 6. Okay, and that is going to be your vertex, and that is going to be your directrix. Again, if you're a person that likes to go through and use equations, that's perfectly fine. If you go up and look, it says that the directrix for that is going to be y equals k minus p. So you say, okay, well, if I do that, I have y equals, my k value is a 1 minus -5. Oh, look, that's what makes it for the difference. I still get y equals 6. If you look at that equation right now, this is what you would have seen in algebra class, right? A y equals equation, in vertex form, quantity squared, all that. But we got to make it into the formula of the conics form so we can get our information. So what I'm going to do is I'm going to add 1 to the other side. So I'm going to say y plus 1 equals 112 times the quantity of x minus 2 squared. Now, if you look at this, I see that the x minus 2 is the quantity that's squared. I'm going to move that, right? I'm not doing any algebra. I'm just moving it to the other side to get that on the left-hand side and the side that's squared on the right-hand side. So I do is move it to the other side. Now, to get it by itself, right, the proper form for conics, I need to multiply both sides by 12. So I have x minus 2 squared equals 12. And of course, you left it as, and you put parentheses to say the quantity 12 times that group of y plus 1. So now, once I have that information, now, or having the correct form, now I can find everything I need. So I say, all right, well, my vertex, well, that's just really easy. Opposite, opposite, right? It's a nice thing. I noticed that, right? I like to do this right away also. I noticed that the direction, well, it opens upwards, right? You say, well, how do you know that so fast, Mr. A? Well, here you can look. I have a positive p value, right? Because 4p equals 12. So I know that p is 3. It's a positive. The x is what was squared. So that's going to tell me that's going to move upward. Okay? So if I start my graph, if I'm at 2, -1, if I go up 3 spots, right? This is my vertex right here. If I go up 3 spots, I go 1, 2, 3. There is my focus, right? Because the parabola is opening upward. To find my directrix, I go 3 steps the other way. 1, 2, 3. I know that right here, that is my directrix. So if you look at a good equation, you can say, oh, my directrix has the equation. It's a horizontal line. So y equals 1, 2, 3, down to 4. And there is my equation. It's moving up, and there's my vertex. Now, this is how you need to do your accurate drawings. Don't just wing it. Don't just be like, we're just going to go like that. No, no, no. You're not going to get full credit. Instead, what you want to use is the focal width. All right, remember we talked about that on the front side. We drew that in green on the front page. So the focal width, well, that's just the absolute value of 4p, or real simply, that's just this number, the positive value of it. So my focal width is 12. So all I need to do is if I cut it in half, I know that from the focus, and we'll actually make this green also to match up, okay? From the focus, if I were to go 6 steps, 1, 2, 3, 4, 5, because it's cut in half, 6x to the right, 6 steps, 1, 2, 3, 4, 5, 6 to the left. If I were to draw that in, that whole, from green dot to green dot, that whole thing is my focal width. Okay, that's the ends of the parabola going through the focus. So now, if I just make a nice parabola, because I could have made that back in purple, but that's okay, right? That, hopefully you drew a little nicer than I did, that whole thing would be an accurate parabola. See how we didn't just wing it like we talked about up there. We actually drew a nicer parabola that goes to those coordinates. That's your teacher's going to be looking for when they're grading your papers because they want you to be more precise than just drawing a random parabola graph, okay? So you be more precise, all right? Awesome. I'm going to, because this is the one that has the quantity squared, I'm going to factor out the 2. So not the x though. The x stays in there. That's a mistake I see students make. They take out a 2x. What are you doing? That's not completing the square. That's being silly. All right, so I'm going to take out the 2. I got x squared minus 6x. I'm going to add the y and move that to the other side. I'm going to subtract the 18, move that aside, and do proper algebra. And I'm moving it over there on purpose because that's what my conics form looks like. So it needs to start getting in that order. Now, if you remember, from completing the square a couple days ago, we would take half of the b value. So half of -6 squared gives me a positive 9. Here's the tricky thing. Because there is that 2 in front of that group, we really didn't add 9. If you think about it, if I were to distribute, don't distribute. Just think about it. if you look at it, if I really, instead of adding 9, I added 18. So in order to balance is I have to add 18 to the other side. That's a tricky one for students. If you can do that, then you are awesome. And then eventually all of you will be able to do that. Just got to practice, okay? So we have plus 9, actually really adding 18. So I'm going to add 18 to the other side. So now it's all set for me, ready to go through and factor, right? This was the process we spent a couple days on. The nice thing is the 18s cancel, so I just get equals to y. I'm not in proper form yet. I need to divide by 2. So x minus 3 squared equals 1/2 of y. Now I'm in the proper form. So now I can figure out, all right, my vertex, that's going to be 3, 0. It's x squared, so I know it goes up or down because it's positive 1/2. That means it's going to be opening upward. Okay, here's a little bit trickier part. I know that 4p is equal to 1/2. Be careful with your fractions. So I know that p is 1/8. So if I start at 3, 0, that's my vertex. I have to go up 1/8 to get the focus. So it's almost like on top of each other, right? And you can't even see it. It's so much on top of each other. My directrix is 1/8 the other way. Whoops. Don't want to go to the next page yet. 1/8 the other way. So that means that my directrix is y equals negative 1/8. That is my equation, my directrix. Focal width, well, focal width is 1/2. I'm going to go 1/4 on each side. So I'm going to go and right there, oops, right there, right there. We'll get rid of this one right here. It's going to get a little messy in here. All right. And so my, as crazy, as tight as that is, the last one was so much larger. As tight as this one is, it's going to go like that. And so this, we know that from here to there, that would be the D value, the distance between there, the diameter, right? As we're looking at that, that's the diameter that's there. And then obviously you have a focus that's right here. And we know that from here to here is your P value. And we know the focal ratio is a simple equation. It just takes the P value divided by the diameter. But again, what it does, it has significance when you're looking at different things like sound for a vision for a satellite dish, things like that. That's where the significance comes in for your engineers down the road. You'll be looking at things like this to measure out when am I getting the best situation? Look, where should that focus be? Again, I'll leave that for all you engineers down the road. Please come back and tell me multiple years from now when you get there. But we're going to have some questions on this. Let's answer how it works. So number 8. Says just find the distance given the focal ratio is 0.3 and y squared equals 120x. So really simply, if I take that equation, I know that I'm just going to abbreviate here, focal ratio is equal to the p value over the d value. So my focal ratio, it tells us, is 0.3. The d value I do not know, right? That's what's asking me, find the distance. So I got to know what the p value is. Well, use the previous stuff we've been working on, right? And off to the side, if I know that 4p is equal to 120, I know that p equals 30. So if I plug that into my equation, right? Just using this equation right there, that's all I'm doing. So if I solve this carefully, be careful with your algebra, let you think it, and you guessed it, 100. So hopefully that's what you got as your answer as you went through and solved that. Okay. So what I would do first thing is plot what you know. When in doubt, draw it out. So if I go out 1, 2, 3, 4, 5, 1, 2, 3, if I were to put my vertex right there and my focus is 5, 4, so there is my focus. Well, I know, or you should see that this is opening upwards, right? And since opening upwards, we know that our basic equation that you've memorized, x minus h squared equals 4p y minus k. I'm going to do is plug my information in. X minus 5 squared equals 4p y minus 3. Right, and just put my information in there. Okay. Now the only thing I need to find out is what's the p value, because I can't leave it like this. And since it opens up and I can see the distance from the vertex to the focus is 1, I know my p is 1. So all I got to do is plug that into my equation. Okay. All right.